Alright, hey everyone, welcome back to the stream. Okay, I don't recognize either of you two that are currently here, so if you want, I can go over the current operating system, what we have so far, because we did start doing this for 2 previous streams. So basically what we have is an application which is able to, well, you're able to input text, so you can do text, and it'll parse the text that you input as commands. And some of the commands that we have so far are peek. So you can peek to different locations in memory. So like, what's at address 22? The value 168. You can also poke. And you can, I think it's address, and then value. And then you can peek again. And let's see, what else is there? Oh, you can clear the screen with CLS. You can copy values from one memory location to another. You can copy a range to another range of memory. You can peek range of memory, so let's just say you want to peek the range from value 0 to 100. It'll print out all those values. And you can also get the character version, which isn't very useful, but it's something. Oh, and you can also hit the up arrow, and that'll bring up the previous command that you input. And you can also use the left and right arrow keys to move through the buffer left and right. And you can obviously hit backspace or other letters, and it'll insert it. That was kind of difficult to implement. I didn't really like that. Let's see. Oh, and something major that we were working on last time was the ability to save and load from files. So you can do like save text, and this is the name of the file, text, and I can say, hi, my name is Sam. There we go. And then I can load that by typing in load text. So it's just load, then the name of the file, and it'll say, hi, my name is Sam, because that's this file right here off your hard drive. And another important feature that we had is the ability to load files as a program. Hold on, I have to lower this music. It is too loud. Okay. So you can type in start, and that will take a path to an assembly file. So let's see. We can do raytracer.asm. And that should load it into memory. Actually, that might be an old assembly file, so it might not work. I have to try it with something else. I think triangle.asm will work. Start triangle.asm. Oh wait, no, I forgot. It doesn't work with assembly files, it works with AEXE files. So executable files. And I don't think I have one for the ray tracer. Oh wait, no, it's right here. So start raytracer.asm.aexe. And there we go. So this is currently how fast the ray tracer is, and it doesn't really have anything. It's not very capable. Right here you can see that it's rendering a sphere, which yeah, it's kind of difficult to tell that it's a sphere. Also, I think I should probably speed this up a bit. The problem is that it doesn't speed up very much, so 1000. There we go. I also have it so that it randomly places pixels instead of doing it line by line, because if it does it randomly, then it's a lot easier to see what the general picture looks like, so it makes it faster for testing, because that way we don't need to wait for every single line all the way through to render. Okay. So this is the ray tracer code that we're going to be editing today. It's quite a bit here. I think a lot of it was copied over from the 3D program, which looks like this. Never mind, it doesn't. It looks like a black screen, I guess. That's weird. It looks like this. So a lot of this line rendering stuff, that doesn't really need to be in the ray tracer, because that does things per pixel, not rendering lines and circles and stuff like that. And the code that we are going to be using is based off of... that's not right. It's based off of this right here, which is a ray tracer that I just quickly made in Shader Toy. So there's a lot of porting to be done, especially because my CPU does not directly work with floats, so I need to use my custom float library and get it working with that. And there's also a lot of functions in here and data types like vector 2 and stuff. I don't have those. Okay, so for every pixel, I think it's... oh wait, no, that's the line by line, and then this is the random place. So I think for every pixel, it sends a ray using these variables. So that's the X, that's the Y, and that's the color. Okay, so send ray. Alright, so for every iteration, the ray moves in the ray direction, X, Y, and Z. So it adds that to its position, X, Y, and Z, every single iteration. And... oh, spheres. Okay, so I have a data type called sphere, which must... yeah, stores the X and Y position of different spheres. And I think I should add just one more sphere. Unfortunately, the way that you have to define it is like this, because so the issue is that a struct can only hold 16 bits of data. So X, that's 16, Y, that's 16, and then that's it. I mean, no, that's 8, and then that's it, because that's a total of 16. So I need to have this array here, which holds another value, which is the Z position. That's the X, that's the Y, that's the Z. And then there's also another one, which is for the color and for the radius. So I want to move this one over a bit and make it smaller. So I'll do... actually, I'll make this one smaller as well. So 20. This one can be 15. Move this one to the right by 67. And move it up a little bit as well. So 40. And let's see what this looks like. Okay, well, it's definitely a lot smaller. I don't see the second sphere, though. Oh, I see. I don't iterate through it, because I set that as a constant value. And there we go. I think I see the second sphere right there. Now, right now I have it so that the brightness of the color of the sphere is actually dependent on how far away it is. And right now it's pretty far away, relatively speaking. So I'm going to just turn that off at the moment. So oops. Alright, so now we can see the two different spheres. They're not two different colors though, so I need to change that. Alright, so 1, 1. So that's blue right there. And I want this to be red, so it's 1, 1, 1, 0, 0, 0, 0, 0. Alright, so now I have a red sphere and I have a blue sphere. Let's also get one more sphere. We can make it like green or something and make it large and over here, I guess. Because we just want to have multiple different surfaces to test reflections off of and stuff. Alright, so let's make this like 25. Make the radius 30. And we'll make it green. Also, let's make it further from the camera, so I'll make it like 70. Oh, I just realized I overwrote that. I have to change those to 2s, and I also need to increase this by 1. Alright, now we have 3 different spheres. And what I don't have at the moment is bouncing. I need to make it so that each ray that sends out from the screen hits a pixel on a sphere or something, and then it bounces, and it can hit another sphere, or another one, or another one. I just make it so that it just returns the first color it hits. So I need to change that. I just realized I need to do vector reflections. How do I do that? Oh wait, I need the normal first. So current location minus shape position divided by shape dot radius. Okay, I can do that. Wait, right? Current location minus shape dot position. Oh, okay. So I need to get 3 different ints. Wait, no, signed ints. So normal X, normal Y, and normal Z. And current location, I think that I changed that to ray pause. Yeah, ray position X. And I need to subtract the shape's current position. So that's X pause. It is pointing towards... Wait, is it pointing towards positive? Direction Z. Yep, it's at... Wait, no. It's at 54, 54, 0. And it's pointing towards the positive Z axis. That's because 54 is... Well, the screen size is 108 by 108 pixels. And so the center of it is 54. 54. And then it's at the 0Z level. So, yeah. That's why this blue sphere, which is at position 54, 54, is in the exact center. Alright, I need to rename this because it's confusing. Should be sphere. So we have to subtract the sphere X position, and then divide this entire value by the radius of the sphere, which would be there's a scroll. Sphere, is that sphere info? Yeah, sphere info dot radius. Okay. So we need to divide by that, then parentheses. Now let's get the other two normal values. So y and z. Y, z, y, z. And then what do I do with the normal after? Actually, let's like use that as the color, because then I can easily tell if it's working. Wait. Oh no, hold on. I think that, does the normal have to be, I think that needs to be a float, doesn't it? Ah, that's not good. Okay, the Astro-8, hold on, I'll show you. You can see with your own eyes. That's how many character colors it supports, 255. Characters are these, or just like letters and stuff like that, which are in the foreground. And then the background, or just direct pixels, it's like 32,000, I think. These are all the colors. Yeah, 32,768 colors. Alright, so what I want to do is normal X, shift left by 8, or normal Y, 5. Actually, let's just leave it at that. See what it does. Nope, that's the wrong command. That didn't work. Okay. Yeah. Definitely an error. Invalid operation exception. Binary operator subtract is not supported for signed int and int. Oh, because this is a normal int. Let's just change that to signed int, even though it doesn't need to be signed. Never mind, that also didn't work. Binary operator OR is not supported for int and signed int. Normal X and 8. Oh, really? Come on. Okay. Okay, so those don't seem to be working. I think that I need these to be, the normals to be floats. So I do have a float library. It's a little bit incomplete, I think, but I can try. Oh, you know what? Okay, so Ducko. So that, the reason why I did that was because I use 15-bit color. So it looks like, if you were to type it out, it would be so that's red, that's green, that's blue. So it just leaves an extra bit left over at the beginning. Here, I can remove that. So that's red, that's green, that's blue. So they all have an equal number of values. And then this last bit that's left over, you can actually use it for things. Personally, I use it as a transparency value, not inside the emulator, but inside like programs and stuff. Because if you set this to 1, then that means you can know that you don't actually want to draw a color. So, for example, I use it for drawing highlights behind characters, because there's no hardware support for that already, because it can only draw colors in the foreground for characters. So I have it so that if it draws colors behind characters, then that means that this value has to be equal to 0, and yeah, that's just what I use that for. And I think it's good to have all of these have the same number of values, although for the characters it is a bit different because it looks like this. So it's red, green, blue, and then there are fewer blue values than there are for red and green. So that's just because I'm limited to 8 bits for the characters. That's the best color amount I can get. So that's what I kind of had to do. Alright, so I think I have functions to convert this to a float, but I need to look for it. Okay, I think it's into float. Yeah, I can use that function, and then I can convert it back to an int if I need it. Into float. See if that works. It does not. Oh, I think OBS just disconnected. That was weird. So used to 4 bits per color channel on 16-bit computers. Wait, 4 bits? Well, because 4 bits. Oh, you mean that you use 4 bits for alpha? Okay, yeah, that would make sense. But my emulator doesn't have that. Or if it did, then I mean you'd have to implement it on your own. So I guess that makes sense. But I mean the original reason why I chose 5 bits in the first place per channel is because the software I was using, AstroSam Evolution, that had a screen emulator that used 5 bits per channel, so I kind of had to like comply with that in order to get a visual output. So that's what I did. Okay, so now that I'm using floats, this is gonna get slow. If it even decides to run. Okay. No, actually, 2. Binary operator divide is not supported for float 16 and int. Where's that? Normal x. Oh. Into float. I have to do that conversion up here as well. Okay, I'm holding Alt. Oh, it's Alt Shift. Ah, so many errors. Wait, operator divide is not supported for float 16 and float 16. Okay, I need to create operator overloads for float, I guess. I thought I did already, but I guess not. I have operator overloads for signed int, but I guess not float. That's not good. Okay, So operator plus float 16. Add floats. Luckily, it's pretty easy because I already made all of the functions required to do this. So minus, then it's sub floats times, that's mult floats, divided by, that's div floats. OBS keep it. Okay, stream keeps dropping out. It's a little annoying. Let's hope it doesn't happen again. Maybe just the fact that it's in parentheses. Oh wait, no, I shifted over by 8. Okay. So let's do an OR for. Oh wait, I already have that. It's just backwards, so let's swap them, I guess. And then B and A. Nope. Still didn't work. Binary operator left shift does not support for signed int and int. Okay, so left shift. Yeah, I don't think I have that one. So left shift. Oh, I hate VS Code when it does that. Signed int and int, and then we just want to return a dot val, switch it over by b. Okay, it's working. So it should be giving me the normals, although those don't really look like normals at all. Oh yeah, I also don't add the Z. I probably should add Z. Wow, that's a lot of scrolling. I can minimize these, I guess. I don't need them. I can also remove all these tests. I have a bunch of tests for when I was still developing the library. So I can delete this giant block of code. There. Should save some space. I don't know if I still have a right float function. Oh, I do, so I can delete this one. It's also a right string. I don't even know what that is. Well, kind of. Well, the operator overloads are all of the number data types interacting with each other. That's what those overloads are for. But what these functions are, well, some of them are just like for the writing, like to screen and stuff, because I had to implement that entire like console thing. But then others of these are for defining signed int and float, because I had to make a library in order to use those, because my CPU doesn't support them already. Okay, so I think instead of shifting this, I should multiply it by, let's see. Well, if this is a float, then I should multiply it by 255. Yeah, 255. But I need to do that before I convert it to an int. So times... And I also need to convert 255 into a float first. All of these conversions I need to do explicitly, which your CPU, I think, or compiled program would normally do on its own in the background. So this is what's kind of annoying, but because in Yabble, I don't think there's a really easy way to like cast. Yeah, that's the word for it, cast. The reason for not supporting floats, yeah, it's a complexity thing, because I don't want to implement that in hardware. I have no idea how I would even do that, actually. Okay, then we can shift this over by 8. I know it's 10, and then 5. Okay. Does that... Those don't really look like normals to me. Actually, maybe. It's kind of hard to tell with the random, so let's change it really quick to render every line, just so I can get a better understanding. Okay, yeah, I think that might be it, actually. I'm not sure what these vertical lines are doing here, though. That's a little weird. But I think each of those looks like a normal, pointing in a different direction. I also set the background to this pink color, just so I can tell, like, when it's rendering, but it's probably gonna be annoying fast. Okay. Now, what's a little bit odd about this is the fact that each front face is a different color. They should all be the same as far as I'm aware, because it's a normal, so it's normalized. Never mind, it's not normalized. How do I normalize this? I see. So I need to get a value. And I need to do, like, a bunch of comparisons, don't I? Let's see. I think I have a comparison function for floats. I also need to find that. I think it's called compare floats. And then I use greater than, less than, equal to. Yeah, equal, greater than, less than. So I need to create an overload for that. So, greater than, return. Cool, now. Compare floats, A, B, oops. And then it uses a character. Isn't that crazy? Because I can't do it an easier way. less than... Really? Less than... Ah, come on. And then equal to. Alright. So now what I have to do is basically just find the greatest value out of the 3. I scrolled too far. And then divide each float by it so that the normal is normalized. Did I miss it again? Come on. No, it's down here. Yeah. Alright. If normal x is greater than normal y, and normal x is greater than normal z, then greatest is equal to normal x. Alright. Else if y is greater than x, or y is greater than z, so they're equal to y. Else greatest is equal to z. And now we have to divide each of these. So normal x is equal to normal x divided by greatest. Y, z, y, z. Now each of these should finally be normalized. Right, that definitely looks a bit funky. Let's let it render out. Basically what we want is each sphere to look kind of the same. Especially like in the center. See right here? Because that means that, because the normals are the same at this location, meaning on the other spheres at that location, because it's the same normal, they should also be the same colors. It looks similar. Okay, yeah, I'd say that's good. That looks pretty good to me. I mean, these are some really weird looking colors. I have no idea why those colors are looking like that. But it's probably just because I'm forcing it to render. I think that's good. How do I do shadows again? Is it normal y? So the colors represent the normal at that location on the sphere. So basically every single ray on the, hold on. So every single ray is coming out of the camera, like this is the camera. So there's a ray coming out. Right now the rays are completely straight, so there's no field of view, which is like this. So right now the rays are coming out like this, parallel to each other. And the sphere, there we go. Each ray is hitting a point on the sphere, and it's finding the normal, which is basically just the direction of that's perpendicular to the surface. So this normal hits, and then this is the value, and it gets this as an x, y, z coordinate pair. So it's like x, y, z. And it gets those coordinates, and then it's writing those directly to the screen. And then this this ray is coming in, and it's being like, so that's the normal. And that normal is basically straight out. And so that has a different color, basically. So that's what the colors represent. They're just an easy way for me to visualize what values are being read from the sphere. So basically, the reason why we need this information is because when we get it, what we can do is we can reflect the ray so that it can bounce off of the sphere in that direction. So how do I do that? So in this ray tracer, what I do is I use a function called reflect to reflect the vector across it like a mirror, because you have to do that not just in 2D but also in 3D, and I don't know how to do that because I have not done that math before. So let me see how to do that. Wow. Stream keeps disconnecting. That's really annoying. I don't know what's going on. It's been working for the past few days. It's very weird. Alright, so dot product of D and N. Dot product is where you multiply each value by all the other values and add them together, right? You should. It's pretty fun. I kind of like working on this because, I mean, at the moment, I've gotten to a point where, I mean, I didn't make the current language I'm using. Someone else made the current language I'm using. But it's so high level that I'm basically just back at where I started, using a high level language to write code. But right now I'm doing it for my own system. So I think that's pretty cool. I like doing that. Yeah, I was gonna port, I was gonna try and port one. But I never got around to it. Yeah, this is some trigonometry stuff. Maybe calculus as well. I don't know. Zero vectors. I literally just want the definition of dot product. Dot product is a product of the magnitude and the cosine of the angle between them. Okay, but then I need to find the angle between two vectors. X. Wait, dot product is just. Huh? I've actually been left more confused than ever. If the dot product is just the first value multiplied by the other two values, then added together. Okay. What other webpage? Or cause. Oh, this. Yeah, but then it says that the dot product of A and B is 3 times 1 plus -2 times 7. So is the dot product just that times that plus that times that plus that times that? I'll try it. Oh wait, and I actually need something. Because dot product is just one part. It's just that and that. Okay, well that will make computation a little bit easier because I don't want to find the cosine of the angle between the two vectors. Because that would take too long computationally. Yeah, if you could do that, that would be helpful. If I don't implement this first. I probably won't, but yeah. So, wait, what did I need? So, d minus 2 times d dot n times n. Alright, so let's just compute the dot product first. Hey, welcome Galactoid. Dot is equal to, let's see, so we're using d and n. D is the input ray, n is the normal. So input ray is ray. Okay, yeah. So that's what I'm going to implement. How do I? Where's the ray direction? Okay, ray direction x, y, and z. I'm going to do ray direction x times normal x. So we need to add that with y and z. So y, z, z. 320 lines for a vector. What language? What? Wait, what? What were you working on? Alright, so that should be the dot product. And then with the dot, C++. Wait, so you were defining a vector too? Like making your own? So d minus 2 times the dot product. So we can multiply 2 up here, because that's easy. So these are all float types. At the end of this, I can multiply by int to float 2. So that should give us the dot product. Let's see how fast this is. It's so fast that it didn't even run. That's crazy. binary operator multiply is not supported for signed int and float 16. Oh no. Ray direction. I need to convert all of these into float. Copy the whole thing. Alright, now with this, it should work. There we go. So that should give us the dot product. Multiplied by 2 actually, so it's 2 times the dot product. And then we have to do d... Actually no, we have to multiply that by n. And n is... that's the normal. So... that means we need 3 new float values for the changed normal x, y, and z. So, changed norm x is equal to normal x times dot y, z. Alright, so now what we have is this part of the equation. So now we just need to subtract those from d. I have to do template, and I wanted to add all the operations that I could ever need. So I have stuff like is orthogonal, is perpendicular, rotate, lerp, perpendicular, cross product, and way more. Okay. I guess that makes sense. Subtract those from D. Wait. Okay, so the new output vector is D minus that. So I can do float 16 new ray direction x is equal to ray direction x minus c norm x, and I also need to convert this to a float, of course. And then we have one for y, 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 z, z, z. And I think at this point what I can do is just change it directly. So I do ray direction x. Oh wait, I don't even need these then. If I just change it right away, I don't need to define new variables for the new values. I don't think this will be visible at all. Yeah, I think it should just give the same. What is going on, actually? Huh. That is interesting. What? Is something supposed to be normalized? Dot product and n must be normalized. N already is normalized, so I don't need to normalize that as well. But I just realized I haven't normalized the new values. Yeah, I need to normalize the ray direction, of course. A UI? Well, like a GUI? I mean, I can. There's support for mouses and keyboard, everything like that. And there's definitely enough characters, and probably it's fast enough to even do pixels, but I'd use characters at least for, like, to begin with. But I don't know if I want to do that, because it doesn't really give me much benefit. Because I can do everything just by typing. Alright, so now we can normalize it by just dividing by the greatest value. Oh, okay, so let's get out paint again. So basically what we have, let's say we have a vector, right? And a vector is just some coordinates, so let's say it's just x and y. But let's say that these values are something like 1, 20. I mean, that gives us a vector, of course, except it's way bigger than we need it, because we want it to only fit within a sphere with a radius of 1. Okay? So in order to change this vector into something that fits within this sphere, but keep the same direction, what we need to do is we find the greatest value inside of the vector, and then we divide by that, so divide by 20. And then what that would give is a vector of 1 over 20 over 1. Wait, is that correct? I think. Alright, so basically what we're just doing is we're shrinking the length of the vector so that it fits within a certain area. Because we need it for that, because we use it for multiplying against things and stuff like that. So, yeah. Let's see if this works. No, it didn't compile. Binary operator divide is not supported for signed int and float on 668. Oh, greatest is set as a... Okay. It's set as a float there, but I don't need it to be. Oh wait, I just realized something. One reason why this might not be working is because I keep it as a float data type, and that won't work, obviously. So let's just see if that was the problem, because I don't want to normalize it if I don't have to. No, it seems I still have to normalize it. So I can do this by, well, with that, and then create a new value, just call it G. It's like greatest, except it's not a float data type, so it should actually work this time. Nope. Nope, that doesn't seem to be. Oh, wait, one reason it might not be working is because I think I set the color. No. Let's see, where do I use Ray RGB? Because I think that's kind of important for handling this. So what is max bounces? Max bounces is 1. Oh, I break right after. Do I ever change the direction back? I should change the direction back, so I think I don't do that. So I'll do that down here. So ray direction Z, I do set that one. But I don't set the X and Y, meaning that they stay, and that's not good because they get all messed up when reflecting. That still doesn't seem to be working correctly. Very weird. Was there an error or something that I missed? No. Because at the moment, the rendering is very messed up. Oh wait, I didn't actually set these. I just redefined them. Or whatever you could call that. I don't know why that wasn't an error. Okay, now it's working. There we go. So this obviously doesn't mean that anything's working at the moment. But what we can do... Could it be casting error with changing from flow to endurance flow? No. I mean, it's working now, as far as I know. I haven't tried reflecting yet. Oh, that's not good. What's going on there? That's supposed to be a blue sphere. But it's blank. And the red one's missing, too. Huh. Oh, maybe I should try breaking. So let's make it random so it's easier to visualize again. Oh, okay, so I think the break was what was going on. Oh, I see. I see, that makes sense. Yeah, it needs the break inside of there because what it's doing is it's iterating through every single shape, and if it finds a shape, which is if this is less than the radius, then it needs to break out of it. Because otherwise it'll go to the next shape and it'll see if it's in there, and if it's not, then it'll reset the color to pink. So now it's good. And let's see. What I want to do is I want to add the color to Ray RGB. Also probably want to reset Ray RGB, like here. And oh wait, no, let's set it equal to 0. Never mind, not 0. I want to set it equal to... Wait, yeah, 0. Huh. Because right here it's plus equals sphere info.color. Oh, so those are two different colored spheres. They're definitely not quite right. Yeah, if there are no errors and the program has failed successfully. That's my motto. Alright, let's not use pink, let's use 0. Okay. Now what I want to do is make it so that when a ray gets reflected, it also gets a little bit of the color that's next to it, that it hits again. So let's try doing that. So we break here, we add the color there. So if we do that, I think we just have to increase max bounces, right? Oh, I think it might be working. Not very well. Maybe. Definitely some weird things going on. Let's see it fully rendered because, first of all, it's very slow. But, of course, I expected that. running a ray tracer on a 16-bit CPU emulator. Okay. Yeah, that's kind of weird. And did it freeze? I think it froze. What? It froze. How did I do that? Let's try that again. Huh, yeah, it's freezing. It's weird. Oh, I should probably set Z equal to something as well. Now it's not rendering at all. What? That's so weird. Let's go back to random, I guess. One pixel. Really? And then what's... is it iteration? Well, I mean, I could do that, but at the moment, I think I'm like past requiring that, you know? Because the system that I'm... Yabble, basically, it's high enough level that looking at the memory can't really tell you that much, you know? Now there's no colors. Seriously? All I did was turn max bounces up, right? So, I don't know why it's not working. Actually, I guess not, because now it's not working at all. Interesting. Okay, that's a few more pixels. I can try reducing this to like 8. Turn up max bounces. Now it's really slow. Or just not working. Come on. So I think what I should do is add just a little bit to the ray direction. And I say that because, actually, hold on, let's try it without normalizing first. But I think what I should do is add a little bit to it in the direction of the normal, because the ray may be getting stuck inside of the sphere, and that's definitely not good. Alright, thanks. See you later. You know what? I think I should draw like a background. Times 18 is right. Minus in plus plus, and then we'll just write a space. This way we can have a background and actually see where it's writing. Okay, so it is writing to a lot of the screen. Although, where it should have colored spheres, it doesn't. Which is a little weird. Maybe I need to increase the distance rather than decreasing it. Like 140. Huh, no, still not working. It's very weird. Let's try normalizing this then, like we were before. Huh. No. I just realized I wasn't writing in color. Alright, now it's writing them. Seriously? So I have to set z equal to max move distance. I don't set it anywhere else, right? Yeah, so it shouldn't be stuck like it was. Alright, let's see if bounces work then. Just reset to 2. Okay. Looks like it's doing something. Let's do it line by line. still a bunch of holes in it. I don't know why that is. Oh wait, iteration does start as 0, so if I divide it by that, then that would probably be why. Take another look. Also, there's a bunch of red and blue spots. That's also very weird. Unexpected. That didn't seem to fix anything. Let's add the normal for the sphere that it hits, because that way we can try and get out of the sphere, in case we are inside of it. Actually, we can't do that here, we need to do that before we check. Oh wait, no, we're not adding it to the direction, we're adding it to the position. So it's ray plus x plus equals normal x. And then we do that for the y's and the z's as well. Oh, that was an error. Okay. Binary operator add is not supported for signed int and float. Oh, that's right. Normals are float type, so we need to do float to int. Okay. Oh, really? Still doesn't seem to be working. And now it froze. Come on. Okay. So we can multiply that by... Oh wait, we need to... Yeah, the normal is normalized to like 1. 2. Int to float. And then multiply it by like 3. Still doesn't seem to be much of an effect on it. It's odd. And it freezes up at 4,400. Yeah, I don't know where that is. Max move distance should be good at 100. There's still a bunch of holes. Try doing this with the color. Shift right by... Oh, wait, no, it's not 5, it's... Oh, it is 5. And then shift right by 2. And left by 2. And then we don't have to shift at all. So it's definitely rendering something, but it's not correct. At least not from what I can tell. And I think this is 5-bit color. Yeah, it is. Okay, so that's 1, 2, 3, 4, 5. I need to do bitwise and on that probably first. Not much of an effect. It's like bits of red. And there's still bits of red. Okay, that's weird. Yeah, the left sphere is definitely green. So that means I must be shifting these wrong, right? Being very excessive with the parentheses because order of operations is a little bit funky. The ray tracer, it will be able to render like 3, maybe 4 spheres. It will have reflections, shadows. Basically, I'm just trying to replicate this one. Well, I mean, not really this one, because I edited this one a bit, so it's a little bit weird looking at the moment. Hold on. I was also going to have like some sort of perspective as well. Oh, there we go. So it's going to look like this. So there's like a reflective sphere, a less one, and an even less reflective sphere. There's also walls, which are all just very large spheres. And I also have a checkerboard ground. So I want shadows like that, reflections, things like that. And I'm just going to try and replicate that inside of the emulator. Still pretty far from that at the moment, but I am kind of having spheres render. But this keeps happening. That's annoying. Ooh, now it's green. Still holes in it, though. I don't know what the problem causing the holes in the sphere is, though. Is it the changing of the ray direction? Okay, it's the changing of the ray direction. But why is that doing it? I'm just gonna wait for this to render. See if the other spheres are affected at all. Alright, so this is the code that was causing the problems. Is it the G? No. Ray position, maybe. Alright, that's green, that's blue. For some reason, these colors are more dull. It's a little weird. I know I divide by this value down here, but it should be starting on iteration 0, so it shouldn't be dividing by anything. And it should be dividing by 1. Alright, so yeah, those are definitely 3 spheres. And when I do plus equals, what happens then? It becomes black. No, I'm gonna correct you. Those aren't circles, they're spheres. Okay? There's a difference. Okay, so when I change this to plus equals, as in adding to the RGB value, it changes the color to black in a lot of spots. Which should not be happening. It gets reset to 0 here. Maybe it's because I defined it up there. And sometimes when you define things, they get set as, like, consts. Nope, that's not it. Yeah, but they are 3D. You just can't tell because there's no shading. Maybe it's that. Now nothing is rendering. Come on. Oh, there's a red dot. Alright, let's comment out all of this normal. Wait, it still isn't working? Why would it still not be working? I fixed all my changes to it though. No. Wait. Is it the plus equals? Hold on. Int color. Ray RGB is equal to Ray RGB plus color. Okay, so for some reason, the plus equals for Ray RGB was not working. Why would it not be working? It might be defined wrong or something. I don't know. That's so weird. Very weird. Let's see if reflection works. Nope, still holes. Ugh. What about without normalization? Nope, that's just as bad, actually. A direct equation that calculates square roots. What do you mean? I thought that was a process that required a loop. Let's try commenting that part out. Okay. So that was the change in direction, though. I kind of need the change in direction. Oh, whoa, what's going on there? That's interesting. Oh, wait, because I added. So if the ray hits, like, 2 locations. Okay. So now there's highlighting where they intersect. I guess that's a thing. Wasn't really on purpose. So it seems I have to set z equal to the max move distance. Otherwise it just doesn't work. Okay. So maybe I shouldn't have that. Wait, that's probably what was causing all the holes. Oh no. I hate missing things like that. Okay, now let's try again. Oh, there's no holes. There's no holes. I mean, there's a little bit of weirdness going on there, but I think that might be because it's double intersecting. Or maybe my normal calculations aren't so great. They might be broken. That's a possibility. And it freezes there. Here, let's see if I don't set z equal to the max. That's even weirder. Huh. Wait, should I subtract these? Wait, ray position Z. I think that one is signed. Oh wait, no, all of them are signed. Instead of doing minus equals, I should do minus. Freezes again. I really need to find the reason why it's freezing. There shouldn't be a reason why. I'm gonna switch this to random. And then it stops. Huh. Let's change the bounces to 1. So it should just render normally now. And then the bounces messes it up. Maybe I shouldn't look at my code because I might have this wrong. So the normal is a normalized current location minus the shape position divided by the radius. So it's ray minus shape position divided by the radius. Ray position x. Wait, isn't ray position x? That's an int. Both of those are ints. So maybe I should convert them both to floats first. That might fix it. It doesn't seem to be freezing yet. Okay, it's still going. Well, that might have been the thing that made it freeze. Oh, wait, hold on. It's doing order of operations wrong here. It needs to subtract first and then divide. Whereas it was dividing and then subtracting. Doesn't seem to be much of a difference visually, though. Just adding some parentheses around here just in case That also doesn't work. Let's see what this looks like. Weird. That's what it looks like. Looks weird. Let's increase this so it tries and get out of the sphere a little bit more. No. That's the wrong one. Here. Separate n equals. Sorry, what? N equals? What do you mean by that? Let's do this minus like 4. Binary operator subtract doesn't support for signed int and int. It's the number, then the equation gets the square root. Irrational squares are rough estimates, but perfect squares are exact. Yeah, let's also add this so that it'll sort of emulate a light source coming from the camera. Actually, that kind of did the opposite. Then the equation gets the square root. So what is the equation? Like, how does it do that? Yeah, that was not a good idea. Also, do I even have reflections? Yeah, I do. Bounces is turned on. So let's just try rendering it. Let's see what the output is. Really splotchy, though. I don't know what that's caused by exactly. And there was something wrong here. I think that's the center of the circle. So that would give a normal of what? Let's just not change direction and see what happens. You have your n equals input. That means that you input the number which is then given the variable n. Then you do root is a variable for the square root equation. You just declare the flow of AD, then it will work. So you change normals, the normal times the dot. Then normal times the dot. Shouldn't that also be times 2? Wait, the dot is times 2. And maybe I should read up more on this. A is pointing towards a plane. Then we have the normal n of the unit length, and we want to find B. Okay. First step is using the dot product to get a vertical vector that will be used in step 2. Step 1, partial formula is 2 times Okay, so yeah, but what is the actual equation that you use to find the square root? Right now you've just like set up a program. Two times a plus negative a times n times n. Oh, well, you didn't post the equation. Now you did. Hmm. This seems it'll be a little more complicated than I initially thought. You see a code example of this. No, really? Rotates. Oh, I can't believe I missed this. Order of operations, of course. It was multiplying 2 by this single or this single value right here, when it should have been multiplying it by the entire dot product. I hope this fixes it. That doesn't look like it. Let's just see if it doesn't freeze like it has been for a while. And it froze. Really? Now, it freezing here most likely is a sign that some kind of operation is happening where there's a for loop involved and it's like invalid. So I don't have no idea what's going on. I have a slight idea what's going on. I'm just not sure where. It might be the int to float conversion, maybe. I hope not, because that was it's used a lot. And that didn't even boot. Still kind of broken. See if it freezes again. Multiply the normal by the dot product. And then you subtract that from the ray direction. Is that what you're supposed to do? Ooh, it's actually kind of working. Maybe. Yeah, let's see what that turns out as. What's D? What is D? D is the... Whoa, hold on. This one says D minus that. And then this one down here says that minus D. Okay, this is looking a lot better. Still a little questionable what's going on. Also, it definitely froze again. Alright, so let's move. Wait, let's move this. Oh, wait. It's actually just this part. There seems to be a bit less artifacting going on. Or at least up here. Down here, it's definitely not looking too great still. Alright, so I have normal and new direction. Then I reflect the direction vector over the normal, then I normalize that, which is this code here. And I also change the new direction by a random amount, just to add noise. And then the new color is based off of the shape's color times 1 minus the iteration over the bounces, or the iteration over the total bounces. Okay, that's definitely looking a lot better. Yeah, look at that. Starting with a ray tracer, and it didn't freeze halfway. Let's go. Okay. Let's see, what's next? Shadow? How do I do shadows again? Yeah, let's look at the code from here. I think I implemented shadows. Those kind of look like shadows. Yeah, let's just... to look at how you do that again. Alright, so that's our first final image. Actually, I should change this text to be something else after it's done. After I'm done with the operating system and ray tracer, what is next? That is a really difficult question because, honestly, I've been thinking about just making an operating system and ray tracer ever since I started the project. Yeah. Well, I plan to actually build the system. I don't know when. I don't know if it'll be anytime soon. But, yeah. I'll try. And after that, that's definitely gonna be the end. The end. Yep. Okay. So I think what I want to do is I want to find the angle. Hold on. Delete. Alright, so what I want to do is I want to find, let's say I have a sphere. That is a box, actually, not a sphere. Brush. Let's say I have a sphere. That's a very small sphere. Let's make it a bit bigger. Sphere. And let's say I also have a imaginary light source. The sun. Wee. Basically what I have are rays that are coming in and hitting that. And I want to see if... No, it's not a circle, it's a sphere. The way that I need to check if it's in shadow is by seeing if the reflection is the same direction as the ray coming off of the sun. Because the closer they are in direction, then that means the more different the normal is. So that I can know that, hey, you know, this area, this should all be in shadow. Because all these normals are pointing away from the sun, or the light source. So I need to look up how to find the difference of angle of two vectors. Vectors. Yeah, I know how to spell. WikiHow? I don't know. Maybe. Sure, WikiHow. Cos inverse of two vectors, the dot product of u and v, divided by the length of u times the length of v. Find each vector's magnitude, use the second theorem. Okay, I don't have cos inverse. Okay. I mean, I could definitely use that, but that's a lot of floats to have, and I'd prefer not to. The angle between two vectors where the tails of two vectors or line segments meet. Each vector has a magnitude or length and a direction that it's heading. So to find the angle between the two vectors, you use the above formula, where theta is the angle between the vectors. Okay. Cos inverse is the inverse of cosine, or the arc cos. The dot product of u and v, and the length, the magnitude of u times v. Okay. What is... I think I read something that it was the cos, the cosine of the two vectors, of the angle between the two vectors, I mean. Alright, so if we do the dot product between the two vectors, then that will give us the cosine of the angle. But the issue is that cosine, we need to convert that into an actual angle. Or do we? Because I think the range for that would be between 0 and 90. Or, well, what would be 1 and 0. So, dot. Alright, and then we do a int. What do you mean draws columns or rows all at once instead of per pixel? Do you mean like it draws lines? Because I think there is an algorithm that draws, like, I don't know, vertical lines or something. Hey, Dor, welcome to the stream. This is what we have for the ray tracer so far. It's looking a little bit weird, but it's going. Alright, so we need shadow is equal to... Actually, let's not use shadow. I mean, not use an int. Let's use a float. Where did you get 36 from, though? What is 36 in that? So the shadow will be the dot product. Okay, so cosine is 1 here, 0 here, so it increases to 0, or it decreases to 0. Then you do the float square root of 36 versus 6.06. the first... What do you mean by the first column? Because... I don't know. Shadow is equal to the dot product. And we subtract 1 from that. Or no, subtract it from 1. Oh, okay. So do int, do float, and then subtract with that 1. So we take this value. So this is a value, that's a value between 1 and 0, because it is 1 here, and then it becomes 0. And then we swapped it, so it's 0 and then 1. And then with those values, so basically what we're doing is we're comparing the vector from the sun and the vector bounced off of, and the more it is towards 0, the more we multiply this by 0. So let's multiply this by 0, 1. That's an 8-bit color then. And then multiply by shadow. I don't think that's gonna work. Alright, bye. Where is this? Binary operator multiplies not support for float 16 and int 676. Oh, I see. Yeah. Makes sense. I should actually do float to int here, and then just completely change that to an int. That sure looks correct, doesn't it? No, it does not look correct. So it's closer to 1 in the light. That looks weird. Interesting, but weird. Time shadow, and we should convert the color into a float first, int to float, and then convert back float to int. Nope, still wrong. Yep, the noisy circle generator. Just what everyone wanted. So we convert this into a float. Then we subtract, no, multiply by the shadow. And then we convert this to a float. Oh, come on. Binary operator subtract is also for int and signed int. Nope, still not working. Okay. This window's way too big. Alright, later. Me? Let me count. Like 7 or 8. Quite a while. Let's multiply shadow by 2. Whoa, really? Still not working. That's actually surprising because I changed it to something, a way where it should be working. Oh, hey, I'm so dumb. Oh no, I can't believe I'm ridiculous. So the dot product is not supposed to be the dot product of the ray. It's supposed to be the dot product of the light and the normal, not the ray. Alright, so we need a new dot product. And we also don't multiply by 2 at the end. So I want the light to be facing like top right corner, and also facing backwards a bit. So that would be a value of what? -1. What's the most complex algorithm I used and where? Oh, I'm not sure. Do you mean related to this project? Because there definitely are quite a few related to this project. For example, just one that I kind of haven't even gotten over yet is the entire float library. It's like down here, where I defined floats and had to create entire functions for modifying and using the entire data type. Yeah, I'm not really sure what the most complex algorithm would be. So we have the normals. Then we want the new ray direction. We want it to be the ray from the light source. So it'd be like -1, 1, and like 5. And that means to divide all those by 5. 2 more months? 2 more months for what? Till my next video? Probably. Or more. And you have 1 year oh no. Oh no, it's been that long? Okay. That is quite some time. Oh wait, I was completely wrong when I said what normalizing a vector was. Yeah, you don't divide by the largest value, you divide by the distance. Which I haven't been doing. Let's see, what's the fastest way to calculate the length of a vector? Because I can do distance formula. Hold on, so that's YZ. Why don't I use Linux? For what? I mean, it wouldn't make much of a difference because I'm using VS Code and my emulator, which has a Linux port, so there's no difference. But I mean, I do use WSL, Windows Subsystem for Linux, and I use Ubuntu. This is basically, I use this every day. And sometimes, you know, I use like Vim and stuff, but sometimes it's just easier to not. That is not rendering, I don't know why. Oh, okay, I see. So basically I just have to square each value and then add them together and then do the square root. Got it. So, greatest. So I don't do this if check for the greatest value. So that was a bad idea. I can leave that. Actually, it's magnitude, right? By default, I'll make that 1. And it's... I think I implemented the square root function, so I'm good with that. Oh, wait. Not for floats. shoot. Square root. I also have a distant function. Okay. Although that is for signed int. Maybe I can multiply and then divide, so I scale it first. That would probably be the best option. Alright, so distant, use that function that I already have. Scale this. Scaled. And then normal. Times int to float, and we can multiply it by a number like 255. And I have to go in for each of these x, y, z. Oh wait, and then for the distance formula, because I only have one x value, I can actually just use zeros. So x, y, z, x, y, z. Alright, so it does x, y, z, x, y, z. So normal x scaled, normal y scaled, normal z scaled. And then 0, 0, 0. Because it's a vector, so it starts at 0. And then each value is just the distance in each direction, yeah. And then I can, now that I have the magnitude, I can convert that to a float. So why is it typing in Russian? There we go. Now we won. Alright. So it's int. No, it's int to float, yep. And we want to convert the magnitude to a float. But we also want to divide it by 255 because we scaled it up here already. So we do divide by int the float 255, and then put all of this in parentheses, and that should be our normal scaled. Let's just write out what the normal value is, because it should actually look normal this time. Pun not intended. Yeah, so this. Nope, it doesn't look any better. Really? Although all these values do look different, which should be good. Should be a good sign. Okay, so I also need to find the normal of the new ray direction. we'll do the exact same process. With ray direction. Instead. Multiply that by 255, so it's scaled. It's Y and Z. I can also make that so it doesn't create a new instance of magnitude, and then we use this and divide by that. And it didn't work. That's a little weird. Binary operator multiply is not supported for signed int and float 16. Let's see. Oh, the ray direction should be a flow. Actually, no, it shouldn't be. Well, it probably should be, because that adds a lot of accuracy. But it also probably slows it down a bit. Let's just try it out, I guess. Flip 16. Flipped to int. That didn't work. Flipped to int. There we go. And then for these, I don't have to convert to int. Or here. Or up here. That's a lot. And I think that's it. Yeah. Of course, it doesn't even render. No errors, I don't think. No. Yeah, I really didn't like that. Maybe if I do this. Or, final thing, use random instead of line by line. Okay, wow, it actually started. Definitely not right, though. Yeah, I'll convert that back. Does he just be working as a float? We put float to int on each of these. Error, of course. Binary operator multiplies not support for signed int and float on 657. So 657. So I convert that to a float for no reason. Okay, it's drawing things. That doesn't look very green to me, but okay. It also froze. Let's see, so we want float to int function here. To int. Wait, no we don't. Int to float. But then it's -1, so it's negative signed 1. And then we want a 1 there. And then we want like a 5 there. Probably without the shadow. No. Why is it freezing so much? And then that's where it stops. Huh. Ray direction x equals ray direction x divided by float to int. Maybe if I try adding 1 to the end, maybe trying to divide by 0, but even then it shouldn't be because I have it so that dividing by 0 is actually safe on the CPU, because you can obviously probably do that pretty easily. So that shouldn't be the problem, but it seems to be because it's working now. Oh, never mind, stopped working. Right when I said it's working now, it stops working. Direction x is equal to that. What's that? What about the normalization up here? How about a 1? See if this lasts any longer. It does not. Oh wow, that didn't render anything. Okay. Yeah, it doesn't seem to work anyways. So max bounces to 1. Yeah, so it is the bounces that are doing it. Let's look at the distance function, because that might not be what we need. Square root, pow. x2 minus x1, y2 minus y1. I could do this more efficiently because I see that it's converting those to negative values. Okay, let's just create a new function called magnitude. x1, y1, z1, and then that's it. Let me just do x1, y1, z1. And then we'll use that instead of the distance function. Should speed things up and also be not a problem anymore. Let's see what this looks like. It did freeze, so it's not entirely the bounce. OBS keeps on dropping out. Come on, let's stop. So float to int. Okay. You can delete that. Bring it over here. We do int to float. Again, stop doing that. Int to float. There we go. See what that does. There's an error? Really? Where's that from? Binary operator divide is not supported for float 16 and int at 668. Divide is not supported for float 16 and int. Int to float. Divided by... Oh, I see, because I'm adding 1. Let's not do that. And it's not working. Okay. Let's look at the int to float code. So let's modernize it a bit. Look at all this. No semicolons anywhere. Except for there, for some reason. spawn by shifting left until the largest digit is reached. Okay. Yeah, I don't see any loops that could go on forever. Meaning, I don't think this is it. We can just see, of course. Still not rendering. Let's also just create a new variable for the magnitude of this. Yeah, still not working. Okay. I'm going to pause the stream for a second. Gonna go get some food. Hungry. So I'll be like right back. Alright, everyone, I'm back. And I brought food. Bagel. Let's see, what were we working on? That's right. Wasn't rendering. So we need to figure out why that is. Butter. So I multiply each of these by 255. And we should divide each of them by 255 as well. Or just the magnitude? Not sure. Well, that's what it is, actually. Yeah. Let's see if it's actually even iterating those. Yeah, it doesn't even look like it's iterating the pixels, so I'm not sure what's going on. Let's try getting rid of this magnitude code. Yeah, so that's what's going on. That's what's wrong. But it also breaks around here. Oh, you know what I should do? When the ray misses a shape, what it should do is, Yeah, it should take. So we have a bool. Ah, bool. Hit. Or no, did hit. Just false. Just false. And only if this is. So if we do hit something, then it will be set to true. Way down here. It's equal to true. And then if it's equal to false, down here. So if it's still equal to false, then that means we don't want to do a bounce. So we do iteration. It's equal to max bounces. Whoa, I just realized. I think that just fixed the problem. Did it? I mean, I don't have normalization on though, so. But I do have max bounces up to 2. So. Unfortunately, it just doesn't seem to work quite correctly. Yeah, it seems to be working. Oh, but then right when it hit the middle, it stopped. Hi, pretty good. Welcome to stream. Right, so the ray direction seems to stay basically the same. Oh, I do think I need that to be a float, though. Yeah, because when I add field of view, it will need to be a float, because being an integer, it won't have enough accuracy. I know we already tried this, but let's actually get it working this time. We don't need to convert into flow. There, there, or over here. We're going to convert this float to int. The progress going. Well, it was at a better state about 20 minutes ago because you could actually see things. But I'd say it's going pretty good. We're kind of stopped at the moment. And that's because we're trying to figure out how to make reflections work, because there seems to be some issues with them going on. And I totally just realized something's going on. Float to int. It was interpreting the entire float type again as an int, because there's no warning for that. And that would give completely different results as well. So I need to do the same thing here. Float to int. Then I don't need to convert into float here anymore. And I don't need to convert here as well. I think that's it, so let's try it out. So it's definitely drawing things. There's green over there, I see blue there and red there, but then there's also a bunch spread out. So I'm not sure what that is all about. Let's try drawing line by line. And it stopped. Okay. Let's revert all of the changes I just did. Yeah, let's revert all this. Okay. And then just try converting this to an int. No, of course it didn't work. Wait, I just realized something. The position also needs to be a float. I guess everything needs to be a float. Let's try this again. And don't do that, but instead, separately, this. And I don't need to convert it here. For all these. Come on. You serious? Close it. Okay. Then into float, don't need those anymore. Or the float to int. Okay, let's try this. Doesn't look right. Because those are green, those ones are blue. Yeah, that's not right. Let's do it line by line. Let's see how much that changes. Yeah, that looks pretty messed up. I don't know what's going on there. And I think it froze. Let's try with no bounces. No difference, it seems. Yeah, no difference. Let's also try without changing the ray direction. Nope, same result. All this normal stuff. Float int. Ray position. Huh. Let's look at the float int function. And modernize it as well. Also look at the denormalized fraction function. If 10 minus the exponent is greater than 60,000. Float minus 15. I wonder why I do 10 minus the exponent. It's not clear. It's been a while since I've worked on that library. Great position X, Y, and Z. Let's just use the function directly, add floats, because this seems to be doing something weird. Nope, still gives the same thing. Ah. Yeah, I think maybe this. It's definitely doing something different now. Still not correct though. Oh, I think that's the top of the circle there. I'm not sure what all that is. It looks like it works until it reaches around there. So. It's like 32. Let's save it as is. And then revert back to int. So I'm not really sure what else I can do now. Just like undo all this. Yeah, I'm not really sure. Alright, I think I'm gonna end it here today for the stream. I might stream again tomorrow. Maybe not, though, because I keep skipping, like, 2 or 3 days at a time, because I might be busy. Thank you, everyone, for watching so far, and I will see you in the next stream. Bye.